Hello students, in this video we are going to discuss the measures of dispersion that we can apply in case of group data that is given in the form of a frequency distribution. Now this is the data I have taken as an example in which class intervals are mentioned along with frequencies and class boundaries are also created or constructed. If we talk about the range is simply the difference between the maximum value of the data and the minimum value. And the maximum value over here is 90. Take away 31. So this is giving you 59 as the range. Now for mean absolute deviation and variance or standard deviation, we need to make use of this formula that should be based upon frequencies. Similarly, for sample variance, we make use of this formula. X minus x bar whole square times the frequencies and then sum of the entire data and then summation f minus 1. Now, before computing mean absolute deviation and variance, we need to first compute mid values for the data. And the mid value for this is, for the first group is 35.5, then 45.5, then we have 55.5, then 65.5, then 75.5, and then 85.5. Now multiply each mid value by its associated frequency and then adding them all would give us the mean for the data. And the first one is 35.5 multiplied by 2 gives us 71 as the product. Now for the second one, this is 45.5 times 5. That's 180 and plus 2.5. So 182.5 it may be equal. Now that's 227.5. So 227.5 is the value in the next one. That's 45.5. 45.5 times 5 is 227.5. Then 55.5 times 8 gives us 444. Then 15 times 65.5, that's 982.5. Then 12 times 75.5 gives us 906. And then 85.5 times 8 is 684. Now adding them all, 684 plus 906 plus, so you can work out on your part as well so that you can check your answers. In the meantime, I am working on my part. The sum is 3315. So x bar, which is the mean, equals to summation f times x divided by summation f. 3315 divided by 50 gives us 66.3 as our answer. Now in the next step, what we do, we take the difference of the x minus x bar values and take the absolute value directly and then multiply this by the frequency. And same I would do directly for the working of variance. So that's 70. The first value is 35.5. Take away 66.3. That's 30.8. And 30.8 times frequency 2, that gives us 61.6. And its square times frequency is 1897.28. So that's the first value. And then for the second value, 45.5, take away 66.3, gives us 20.8. 28.8 times 5, that gives us 104. And then for raising it to square, again multiply this answer by 20.8. That's 2163.2. Now for the next value, that's 55.5 minus 66.3, that's 10.8 times 8 gives us 86.4, and then multiply this answer by 10.8 again, gives us this answer. Then 65.5 take away 66.3, that's 0.8, and then multiply this by 15, gives us 12. Then again multiply by 0.8, gives us 9.6. And then 75.5 minus 66.3 gives us 9.2 times 12, which is the associated frequency, gives us 110.4. And then multiply this by 9.2 again, gives us this value, 101.568. Then the last one is 85.5 times 8, that gives us 85.5 take away 66.3, and then multiply this by 8, gives us 153.6, and multiply this again by 119.2, gives us 2949.12. So adding these values, so the sum of this is 528. The mean absolute deviation sum is 528 divided by 50, gives us 10.58, 10.56 as the answer. So on the average, in absolute terms, on the average, each and every observation of the data is 10.56 units away from its mean. This is what the interpretation is. Now, for variance, we add the values of the last column. That's 8968. So S square is 8968 divided by 50. That's 179.36. And then the standard deviation is simply the square root of this answer. So the square root of 179.36 is 13.39, that is roughly 13.4, rounded off to two decimal places. So this is how we determine the value of the variance and then standard deviation. So mean absolute deviation is 10.56, whereas standard deviation of this data is 13.4. And now going to the next one, which is the quartile deviation. And we know that quartile deviation has a formula Q3 minus Q1 divided by 2, and Q1 for group data is equal to L plus H upon F times summation F divided by 4 instead of 2, because this time we are not working for median but for quartiles. Similarly, the formula for Q3 is L plus H upon F, and this is 3 quarter, that is 3 times summation F divided by 4. And what we do to identify quartile, Q1 can be first determined as C1 summation F divided by 4. Okay, summation F 50 divided by 4 gives us 12.5. So what we do, when we need to construct CF values or column for CF values first. That's 2, 5, then 15, then 30, then this is 42, and that's 50. So we need to highlight the group in which Q1 falls, which is this one, because CF corresponding to the Q1 value, which is 12.5, is 15. 12.5th observation will be located in this group. So everything we take from this group, its lower class boundary is 50.5. So we substitute here 50.5. The class width is 10. The frequency of this group is 8. Then summation F by 4 is 12.5. And the cumulative frequency preceding to this group is 5. So we substitute everything over here. 12.5 take away 5 gives us 7. So first of all, 7 divided by 7 multiplied by 10, and then divided by 8. Take care of BODMAS rule over here. And then this is coming up 8.75, and then add it to 50.5, which is the lower class boundary of the lower quartile group. So lower quartile Q1 is 59.25 for this data. And now for the third quartile, what we do for Q3, summation F divided by 4, which is 3 times 50 divided by 4, is 37.5. So we will now locate the group in which 37.5th observation may be located, and this is this one. So that's Q3 group, and this was Q1 group. So lower class boundary we take of this group, which is 70.5. plus class width is same 10, frequency of this group is 12, then 3 times summation f divided by 4 gives us 37.5, and then we take the cumulative frequency preceding to this group, which is 30. Preceding frequency to the Q3 group we take into consideration, and that's again 7.5. The difference of 37.5 and 30 should be divided by 12 now, multiplied by 10 gives us 6.25, and this 6.25 should be added to 70.5. So the answer is 76.25 is the estimated value of Q3. And now QD is simply Q3 minus Q1 divided by 2. That's 76.75. 76.25 and minus 59.25 gives us 17 divided by 2, and 17 divided by 2 is equal to 8.5. So 8.5 is a quartile deviation for this data. That's all from this video.